So let's talk about polygons. Polygons being straight-sided shapes, the smallest of which would be triangles, and then you've got quadrilaterals and so on. So there are three key things that you need to understand in order to do polygon questions. The first of those is you need to understand what they mean when they talk about a regular polygon. So a regular polygon means that they have equal size sides and equal angles, and it's the second of those two things that is most important, generally speaking, in the questions you're going to do. So a regular triangle is an equilateral triangle because it's got sides that are all the same and all the angles are 60. A regular quadrilateral is the square because all the sides are the same and all the angles are 90 degrees and so on. So this is more or less the regular hexagon shape that you would imagine to see. So that's what regular means. So it means all the angles are the same. So if we were talking about this, all these angles inside here would all be the same size, which obviously could be a very useful fact to know. The next thing that we need to know and understand is the terms interior angle and exterior angle. So the interior angle, I think, is fairly self-explanatory. It's this angle inside. What most people aren't aware of is what we mean by the exterior angle. It doesn't mean all the way round here. So the exterior angle is actually this part here. So what we can see is that the interior angle and the exterior angle sit on a straight line. So that means the interior angle plus the exterior angle add up to 180 degrees, which is another important fact to know. And then finally, the last piece of information that you need to have memorized is that if we go round, if we were to draw on all the exterior ones all the way round, and then if we were to add all those angles together, they will always equal 360 degrees. I don't just mean on a hexagon, I mean on any polygon at all. So that's a really useful fact to remember. So let's keep those to one side while we have a look at some examples. So here we have a regular pentagon, and they're asking us to find the size of each of the interior angles. So because it's regular, they're all going to be the same size. So that's helpful. Now let's look at the facts that we've got here. Now I could work out what that angle was if I knew the exterior angle that's out here. And I can work out that exterior angle because I know that the total of all those angles is 360 degrees. Because it's regular and they're all the same size, and we've got 5 of them, each exterior angle is going to be equal to 360 degrees divided by 5 in this case. So 360 divided by 10 would be 36, so we double that to get 5. So the exterior angle here is 72 degrees. So then we look and use this fact that we know that the interior plus the exterior equal 180. So the interior angle that we're trying to find, this x, will be 180 minus the 72. So that means it will be 108 degrees. So x is 108 degrees. Okay. Now, part B here, we've got 3 of these pentagons joined together, and they want us to work out what the angle is in here. So if we use what we've just learnt, we know we've just worked out these angles here. The interior angles of each of these is the same as the x we've just worked out. There's 3 of those plus that little bit form the circle. They're points around angles around a point fact there, so they add up to 360. So we want 108 times 3 so that we can add up these 3. So that's going to give us 324 degrees. So this angle here is what we're going to get when we do 360, take away 324, and that's going to give us 36 degrees. Let's look at a couple more examples. Okay, so this time we have a regular hexagon, so a six-sided shape. And we're being asked to work out what this angle is here. Now, we need to look at this and understand. So this is going to actually use the regular in both senses. So regular means that all the sides are the same length. Now, I don't really much care about the ones around the other ones, but the fact that these two are the same length means that we've now got an isosceles triangle. So that means that this angle and this angle are the same. So if I could work out this angle here, then I could work out these angles here. Now this angle, of course, here is the interior angle of this regular hexagon. And in order to find the interior angle, we first need to find the exterior angle. So we know they all add up to 360. Because it's regular, they're all the same size, and there's 6 of them. So the exterior angle of a hexagon, a regular hexagon, is going to be 360 divided by 6, which is going to give us 60 degrees. So that means that the interior angle is going to be 180. Take away the 60 equals 120 degrees. So this angle in here is 120 degrees, which means that these two angles are what's left over once we take that away. So 180 minus 120 takes us back to the 60, as you can see. So that's what these two angles add up to. Because they're the same angle, because they're isosceles, that means that if we do 60 divided by 2, we can finally get our answer and work out that x equals 30 degrees. Let's look at a couple more examples. So here we haven't got a picture. You don't always get a picture, okay? So this one says we've got a regular polygon that has 24 sides, and they want us to work out what the size of the exterior angles would be. So this brings us back to this useful fact here. So if we add them all up, we get 360. There's 24 of them. So if we do 360 divided by 24, we can find out what our angle is. Now notice I've written it this way because I think some of you might find it easier to solve this way. I know it says use a calculator, but if you didn't have the opportunity to use a calculator. So if you know something about your 12 times table, you can see we've got 2 12s here and 3 12s here. So if we divide by 12 top and bottom, we're going to get 3 12s if it was 36, so 30 because it's 360, and 2 on the bottom, and 30 divided by 2 is 15. So each of the exterior angles in that polygon are 15 degrees. The next question tells us that the exterior angle equals 20 degrees and asks us how many sides the polygon must have. So again, we're going to use this fact here. So 20 times whatever the number is must add up to 360. So we can work that out by doing 360 divided by 20. We cancel those by dividing by 10. So we've got 36 divided by 2, which gives us 18. So there are 18 sides. Okay. Here, this one tells us that our interior angle is 174 degrees, and asks us for the number of sides. To work out the number of sides, we first need to work out the exterior. So the exterior is 180, take away the interior, so that is 6 degrees. 6 times however many sides there are has to add up to 360. So to find the exterior, we're going to do 360 divided by 6. So 6 into 36 would go 6, so it's 60 this time. So we've got 60 sides. Okay, just going to look at a couple more, slightly more challenging ones, just to give you a bit of extra practice here. So at the top here, we've got a 1, 2, 3, 4, 5-sided shape. So that's a pentagon. It doesn't look like a regular pentagon, but it is a pentagon. Okay. We're told these two angles are right angles, and these two angles we're given as well, and we need to work out what this angle is at the top. So if we knew what all these angles inside added up to, we could do that. Now, how are we going to figure that out? We're going to have to pretend we're talking about a regular pentagon, because the angles add up inside of an irregular pentagon to the same number that they do in a regular pentagon. Okay, so if we were talking, I'm really rubbish at drawing these, but here we go, there's a more regular pentagon. So we know how to find exterior angles because of this fact here. So it's a pentagon. We've already done that one already. So it's going to be 360 divided by 5, which was 72 degrees. So the interior angle is going to be 180 take away 72, which is 108. And there are 5 interior angles. So the total of the interior angles is going to be 108 times 5, which is going to give us 540 degrees. So now we know that these angles all have to add up to 540. So we need to add together the ones that we've got. So we've got two 90-degree angles, so that's 180. We've got 160 and we've got 115. So we add those all together, we're going to get 455. So then we're going to need to do 540, take away the 455 to work out the missing angle there. So that's going to be 85 degrees. So X here is 85 degrees. So although that wasn't actually a regular polygon, we had to go to understanding a regular polygon to figure out this. So every single polygon, every single pentagon rather, sorry, the angles, the interior angles always add up to 540. Now, nobody expects you to remember that as a fact, but they do expect you to be able to figure it out using something like this. Okay, now I'm going to talk about how a slightly different way that we can do that, because we've got a similar one here, but this time we've got 1, 2, 3, 4, 5, 6 sides, so that makes that a hexagon. And because I don't want to actually draw on that picture because it will make it too messy, I'm going to show another way that we can figure out what the angles inside add up to. So here's what a regular hexagon roughly looks like. Okay, now if you pick one point and stick with that point and draw lines to all the other points that you can reach, so that to that one is already there, if you like. Now what you can see we've ended up with is 1, 2, 3, 4 triangles. And we know that the angles in each triangle add up to 180. So if we do 180 times 4, we will figure out what the total of all these inside angles is. So do it in 2 steps. So 180 doubled, hopefully you recognise, would be 360 because it's a full circle. Double that again and we're going to get 720. So all of these need to add up to 720. So we're going to add up these angles. So we've got 130 and 170. That makes 300. 410, 485. Oh, sorry, I missed one, didn't I? There's the right angle up there, so we need to add another 90 on. So altogether, we've got 575. So we need to do 720, take away the 575, and that's going to give us 145 degrees. So that's how we do polygon questions.